You wake up tomorrow morning and something feels wrong. You check your phone. It's 9 in the morning, but outside your window, it's still completely dark. Not the darkness of nighttime with stars and moonlight, just absolute empty blackness. You turn on the news and see the same message scrolling across every channel. The sun has exploded. This is not a drill. Seek shelter immediately. That star at the center of our solar system, the massive ball of nuclear fusion that gives us heat, light, energy, and moderately acceptable complexions, just detonated. 150 million kilometers away, our sun, the anchor of everything we know, has gone supernova. And you have approximately 8 minutes before the effects reach Earth. This is what would happen if the sun exploded tomorrow. And spoiler alert, it's not going to be a fun day. The sun's actual timeline. We have time, but not forever. Before we dive into the nightmare scenario, let's talk about what's actually going to happen to the sun. The good news is that the sun isn't exploding tomorrow. The bad news is that it will eventually die, taking us all with it, unless we figure out how to leave the solar system. The sun is currently about 4.5 billion years old. It's a middle-aged star, roughly halfway through its lifespan. It has another 5 billion years or so before it runs out of hydrogen fuel in its core and begins the process of dying. When that happens, it won't explode in a dramatic supernova like we're imagining today. Instead, it will go through a long, slow death that takes place over hundreds of millions of years. First, the sun will expand, becoming what's called a red giant. It will swell up so large that it will likely engulf Mercury and Venus, and possibly even Earth. The surface temperature will actually decrease as it expands. That's why it's called a red giant, because cooler stars appear red. But the sheer size means Earth will either be consumed or roasted beyond recognition. After the red giant phase, the sun will shed its outer layers in beautiful but deadly planetary nebulae, glowing shells of gas and dust ejected into space. What's left behind will be the core, which will shrink down to become a white dwarf. A white dwarf is essentially a dead star, a dense, hot remnant that will spend the next several billion years slowly cooling down until it becomes a black dwarf, a theoretical object that doesn't emit any light or heat at all. But that's billions of years in the future. Today we're imagining something much more catastrophic and immediate, the sun exploding tomorrow in a massive supernova. This wouldn't actually happen to our sun. It's not massive enough to go supernova. Only stars at least 8 times more massive than the sun can explode that way. But let's imagine it anyway, because the scenario is both terrifying and fascinating. The explosion. You wouldn't see the fireworks. When you imagine the sun exploding, you probably picture a spectacular show, a massive burst of light and energy, a cosmic fireworks display visible across the entire sky. With a name like supernova, you'd expect something magnificent and awe-inspiring. But in reality, you likely wouldn't see anything dramatic at all, at least not immediately. The sun is 150 million kilometers away from Earth. That sounds like an enormous distance, and it is by human standards. But in cosmic terms, especially supernova terms, that's uncomfortably close, dangerously close, catastrophically close. Light from the sun takes about 8 minutes to reach Earth. That means when you look at the sun, don't actually look directly at it. That's bad for your eyes. You're seeing what the sun looked like 8 minutes ago. If the sun were to explode right now, you wouldn't know about it for 8 minutes. The light from the explosion would take that long to reach you. So for 8 minutes after the sun exploded, everything would seem normal. The sun would still appear to be shining in the sky because the light that left it 8 minutes earlier is still traveling toward Earth. Birds would still chirp. People would still go about their morning routines. Coffee would still brew. Everything would be fine. And then exactly 8 minutes after the explosion, the effects would hit. The first thing you'd notice is the light. Not the spectacular explosion you might expect, but something stranger. The sun would suddenly appear much brighter, blindingly bright, for a brief moment as the initial burst of radiation reached Earth. If you were looking at the sky at that moment, you'd be blinded permanently. The ultraviolet and X-ray radiation would be intense enough to cause immediate damage to anyone exposed. Then, almost immediately, the sun would dim and disappear. The light show would be over in seconds. What followed would be darkness. Permanent, total darkness. The immediate catastrophe: half the world boils. The supernova would release an unimaginable amount of energy in all directions. This energy travels at the speed of light, which means it hits Earth at the same time as the visual confirmation that the sun has exploded. For the half of Earth facing the sun at that moment, the result would be instant catastrophe. The side of the planet facing the explosion would be hit with a wall of radiation and heat so intense that the surface would begin to boil. We're not talking about hot summer day temperatures. We're talking about temperatures that would vaporize water instantly, ignite forests, melt rock, and turn the atmosphere into superheated plasma. Anyone on the day side of Earth would be killed instantly, not from the heat reaching them through the atmosphere. They'd be dead before that happened. The intense burst of gamma rays and X-rays from the supernova would cook them from the inside out, their cells literally boiling from the radiation exposure. It would be over in seconds. They wouldn't even have time to realize what was happening. The lucky half of Earth, if you can call it lucky, would be the side facing away from the sun. They'd be shielded by the bulk of the planet itself. They wouldn't be hit directly by the initial burst of radiation, but they wouldn't escape unscathed. The temperature on the protected side would still rise dramatically. The atmosphere would begin to heat up from the energy being absorbed on the day side. Within hours, temperatures on the night side would climb to 15 times hotter than the sun's current surface temperature. The sun's surface is about 5,500 degrees Celsius. 15 times that is over 80,000 degrees. Nothing survives 80,000 degrees. The oceans would begin to boil. The atmosphere would start to burn. Any life that survived the initial blast would be cooked over the next few hours as heat spread around the globe. Earth would become a roiling ball of superheated gas and boiling rock, and that's just the immediate effect. Things would get worse. Darkness falls. Earth becomes a frozen rock in space. Let's say, hypothetically, that the supernova somehow wasn't strong enough to completely sterilize Earth. Maybe you were deep underground in a bunker. Maybe you were in a submarine at the bottom of the ocean. Maybe you were just incredibly lucky. You survived the initial blast. Now you have to deal with the fact that the sun is gone. Without the sun, Earth would be plunged into permanent darkness. No dawn, no sunset, no daylight ever again. The only light would come from the stars, which would suddenly be much more visible without the sun's glare washing them out, and from cities as long as the power grids held up, and from fires as the world burned. But darkness would be the least of your problems. The sun provides almost all of Earth's heat. Without it, the planet would begin to cool rapidly. How rapidly? That depends on several factors, but we can make some estimates. Within 1 week, the average surface temperature on Earth would drop to around negative 18 degrees Celsius. That's cold, but not immediately deadly if you're prepared. It's roughly the temperature of a freezer. Bundle up, stay active, burn fuel for heat, and you might survive. Within 1 year, temperatures would plummet to around negative 73 degrees Celsius. This is where things get really difficult. At these temperatures, the oceans would begin to freeze from the top down. The water at the surface would turn to ice, creating a growing ice sheet that would eventually cover the entire planet. You might think frozen oceans would mean no water to drink, but actually the ice could be melted for water if you had a heat source. The bigger problem is that as the oceans freeze, they'd lock away most of Earth's remaining heat. The oceans store enormous amounts of thermal energy, and once they're frozen, that heat is gone. Within 1,000 years, assuming you somehow survive that long, Earth's atmosphere would begin to freeze and collapse. The nitrogen and oxygen that make up our atmosphere would literally fall out of the sky as snow. Eventually, the atmosphere would be reduced to a thin layer of frozen gas on the ground. Without atmospheric pressure, any liquid water that somehow remained would instantly boil away into space. The surface of Earth would be exposed to cosmic radiation and meteor impacts with no atmosphere to protect it. At that point, Earth would be completely lifeless on the surface, a frozen, airless rock drifting through space in permanent darkness. Earth's orbit. Goodbye, solar system. But there's another problem that would happen much sooner. Without the sun's gravity, Earth would lose its orbit. The sun contains 99.8% of all the mass in the solar system. Its enormous gravitational field is what keeps Earth and all the other planets in their orbits. We're not standing still. We're racing around the sun at about 30 kilometers per second, held in place by gravity's invisible tether. If the sun exploded and its mass was suddenly dispersed, that gravitational tether would snap. Earth would no longer be pulled toward the sun. Instead, it would continue in whatever direction it was moving at the moment the sun's gravity disappeared. Essentially, Earth would be flung out of the solar system like a stone from a sling. We'd go flying off into interstellar space, probably never to return. Our velocity would be roughly 30 kilometers per second. The same speed we're already moving in our orbit. That's about 108,000 kilometers per hour, fast enough to cross the distance from New York to Los Angeles in about 40 seconds. Where would we end up? That's hard to predict. Space is mostly empty. The chances of Earth crashing into another star or planet are astronomically small. More likely we just drift through the void between stars for millions of years, a frozen dead rock in the darkness. There is a tiny possibility that Earth might eventually be captured by another star's gravity and settle into a new orbit. If that happened, and if the new star was similar enough to our Sun, and if Earth ended up at the right distance from that star, then maybe, just maybe, life could return to our planet billions of years in the future. But the odds of this happening are so small that it's barely worth considering. The only chance: underground survival. If we knew in advance that the sun was going to explode, if we had months or years of warning, would there be any way to survive? Maybe. Just maybe. The surface of Earth would become uninhabitable, but underground is a different story. Just a few meters below the ground you walk on, the Earth maintains a relatively constant temperature of about 17 degrees Celsius year-round. This is because the Earth's interior contains residual heat from its formation billions of years ago, plus heat generated by radioactive decay of elements in the crust and mantle. That heat wouldn't disappear just because the sun exploded. The Earth's core would continue generating heat for billions of years. So theoretically, if you went deep enough underground, you could survive in a temperature-controlled environment, even without the sun. The plan would be simple in concept, but incredibly difficult in execution. Build massive underground bunkers capable of supporting human life for centuries, or even millennia. These bunkers would need power sources independent of solar energy, nuclear reactors probably, since there would be no wind or hydroelectric power without the sun. Food production systems, underground farms lit by artificial lights, growing crops hydroponically, or in nutrient solutions, water recycling systems to purify and reuse every drop, since there would be no more rain, air recycling systems to maintain breathable atmosphere, since the surface atmosphere would eventually freeze. Everything you need to survive, produced in an artificial environment deep beneath the frozen surface of a dead planet. Could humanity survive this way? For how long? With enough preparation and resources, we might be able to survive for 1,000 years or even longer underground. By that point, hopefully, we'd have developed the technology to leave Earth entirely and find a new home elsewhere in the galaxy. But let's be honest, the odds of humanity surviving a supernova at our current level of technology are basically zero. We don't have the infrastructure, the resources, or the time to build the necessary bunkers and support systems. If the sun exploded tomorrow, we'd be done. The reality: it won't happen overnight. The good news, and there is good news, is that when the sun does eventually die, it won't happen overnight. It will be a slow process taking place over hundreds of millions of years. The sun will gradually get hotter and brighter as it ages. In about 1 billion years, it will be hot enough that Earth's oceans will begin to evaporate. In about 5 billion years, it will begin expanding into a red giant. We'll have plenty of warning, plenty of time to develop the technology to leave Earth and colonize other planets or star systems. And when the sun does die, it will create something beautiful. The outer layers that it sheds will form a planetary nebula, a glowing shell of gas and dust expanding into space. This material will eventually be incorporated into new stars and planets, continuing the cycle of stellar birth and death that has been going on since the beginning of the universe. Who knows? Maybe the atoms that make up your body right now came from a star that died billions of years ago, and maybe billions of years in the future, those same atoms will be part of a new world orbiting a new star, with new forms of life wondering about their place in the cosmos. The universe is constantly recreating itself. Stars die so that new stars can be born. It's a cycle that's been going on for over 13 billion years and will continue for trillions of years to come. Conclusion: the sun isn't going anywhere soon. If the sun exploded tomorrow, it would be game over for Earth and everything on it. Half the planet would be vaporized instantly. The other half would be cooked shortly after. Even if you survived underground, you'd be facing a future of permanent darkness, frozen oceans, collapsing atmosphere, and drifting endlessly through interstellar space on a dead planet. The only consolation is that this scenario is purely hypothetical. Our sun isn't massive enough to go supernova. When it does die billions of years from now, it will do so gradually enough that future humans, if they still exist, will have plenty of time to evacuate. But the scenario does remind us of something important. We live at the mercy of our star. The sun gives us everything: warmth, light, energy, life itself. Without it, we're nothing. We're a fragile species living on a small rock in space, entirely dependent on a ball of nuclear fire that we have no control over. So maybe it's time we started working on a backup plan. Maybe we should be developing the technology to live on other worlds, to travel to other star systems, to ensure that humanity's future isn't tied to the fate of a single star. Because someday, not tomorrow, but someday the sun will die. And when it does, we better be ready. If you enjoyed this exploration of what would happen if our sun exploded, subscribe for more scenarios that make you appreciate how fragile our existence really is. And maybe leave a comment about whether you think humanity will ever leave the solar system before the sun dies. Stay safe out there under our temporary star.